give a big round of applause to Pierre, and please make it loud.
Thank you, Julian. Hello, everybody. My name is Pierre. I'm a solution architect at AWS Amazon Web Services, and I'm here to talk with you about developing brand new type of applications where we will try and find a way to develop the applications and the backends without any server. So this is a new way of trying to develop the application so that you can focus exactly on what you have to do for your companies and do not focus on infrastructure, right? So I will have something like 45 minutes for a presentation. I have a gazillion slides. I can present all of them, but the main purpose here is that you ask questions. The session is filmed, so please do not hesitate to ask questions, and that would be my pleasure to answer you about all these questions. I know we're in France. I know it's not very easy to speak in English when it's necessary, so if you feel shy or do not want to express yourself in a foreign language, just wave, ask your question in French. I will just rephrase it in English, and we will go ahead, okay? Is everybody okay with that? Yay, wonderful, excellent. So let's go with it. Is anybody here using Amazon Web Services, cloud services? Wonderful, that's great. That's not enough, but that's great. Many people are using these services. In terms of services, among the people that are using these services, is anyone using Amazon Lambda? None? Excellent, this is a presentation about Lambda. Anyone using API gateway? Neither? DynamoDB? Wonderful. So all the presentation is based on these kind of services. So this would be a great presentation, and you will see that we can develop an entire mobile application without any server infrastructure in the back end. So let's go for it. This is what we're going to see during the presentation. First of all, we'll go through some services that we will use in this presentation. AWS Lambda, that is managed code, and you will see that this is pretty easy to deploy your own code and make it managed by Amazon Web Services. Using Amazon Cognito services that help you do federation services and identity management. API gateway, that is a gateway for building RESTful APIs, and we will use all the services together to try and build an application in the next 45 minutes if we have enough time to do that. Great. A little bit about Lambda and a small deep dive into this kind of service. Does anybody know about Lambda? I know none of you have already used it, but does anybody know about Lambda? Yeah, at least 2 people should know over there. We have Amazon people here, so they actually should know that. So Lambda is a service that manages your code. So you provide code, you provide a function in a specific language, you provide that function to Amazon Web Services, and we will take care of that code. We will execute that code based on events. So whenever you have an event, we will execute that code with all the parameters that go with it. It scales automatically, so you don't have to care or worry about the number of parallel executions. It does that automatically with no problem. Just put your code and ask AWS to execute it based on events. So what kind of events we can have here? So it's completely serverless, so there is no way to have and no need to have a server with an operating system, kind of a framework, or environments, or variables, or security concerns. None of them. You just put your code. This code is completely scalable. The scalability is handled directly by AWS. So if you only have one user executing a Lambda function, then you will have one Lambda function. But if you have 700 users trying to execute that function, then you will have several hundred instances of that function. All that is handled gracefully by AWS for you. And last but not least, we have a sub-second billing. So you will be billed based on the duration of the execution of your Lambda. and the slice is 100 milliseconds. So you will be billed by 100 milliseconds slices. The more the execution, the more the bill, but the less the execution, the smaller the bill. This means that for people like you, startups, when you begin to deploy a new application or a new service, you often have a very high ramp up. So at the very beginning, you want to have your own infrastructure running with the high and right level of SLAs, but you don't want to pay a first step. This is the case with Lambda, just because if there is no execution, you won't be billed anything. But your code is already there, ready to run when the first customer arrives on your site. So this is for the benefits of Lambda. I think I had a clicker. Here it is. What can we do with Lambda? Lambda is your own code. There is nothing specific. There is nothing particular or peculiar to add to your code. Just define a function, like a hello world kind of function. Write it, push it, and it's immediately executable. The compute power levels define the quantity, the capacity of CPU power that you want to allow to your Lambda. So we can begin with very small type of power that we can provide you with, beginning with 128 megabytes memory, going up to several gigabytes. So you define what would be the power allocated to your Lambda function. And this Lambda function can be invoked in many different ways. I said a few seconds ago that it was event-driven. Yes, it's based on events. So whatever event arrives on your platform, you can have a Lambda handle it. And among those events, for example, you push a file somewhere, this is an event. You modify a record in a database, this is another event. So imagine a backend application that creates records in a database. Then each time you put a new record or each time you modify a record, then you can have a Lambda handling this event, either because you want to do backups operations, for instance, or just because you want to verify the consistency of the record. This can be done with Lambda. And it's fully automatic. You don't have to do anything else than just saying, I map my Lambda function with that specific event, full stop. And just to be sure that the security is not an issue, we have a very, very fine-grained permission control. So you can define who can invoke a Lambda function, and you can define what a specific Lambda function is allowed to do. So for instance, I said, when you push a file somewhere, this is an event. This event will fire or trigger a Lambda, and this Lambda may be only allowed to read the specific file that you just posted. So you can have very fine-grained security permission controls on your Lambdas. How do you do that? Easy. Just write your code. That's it. Write your code. You can test it locally. We have today 3 types of languages that are supported, like Java, JavaScript, Node.js, and Python. So just write your code and you're done. Test it locally if you want, or you can deploy it directly to Lambda and test it directly from Lambda. And that's it. The only thing you have to do afterwards is just monitor the correct execution of your Lambda function. That's it. All the rest is taken care of by Amazon Web Services. Wonderful. What could be the use cases, or what could be the kind of services that we can match with Lambda? Many, plenty. You name it. The first fun one may be using Amazon Echo. Who knows Amazon Echo? Great. Amazon Echo is a virtual assistant. You can speak to Amazon Echo. You can ask questions to Amazon Echo, and Amazon Echo will answer you based on the questions you make. And you know what? Each time you ask a question to an Amazon Echo, there's a Lambda behind that handling your own question, right? So for example, you can have many different Lambda functions, executing behind an Amazon Echo. I said also that Lambda can be invoked based on events. Events like S3. Everybody knows about Amazon S3. S3 is a storage, object store that is actually the first service that we provided back in 2006. So when you push a file to S3, then this can trigger a Lambda. And with many other services, we will not spend time on all the services, but actually there are more services to come in the next months and years. Okay, so Lambda is the way to have code executing whenever you need something to be done automatically. Wonderful. So let's go and try and set up our, let's say, interest matching application. We are trying to build a mobile application where we want people with the same interests to be matched based on their location. So when we build an application, the first questions we ask ourselves is, how the hell will I set up my backend services? When you have a mobile application, then you need to specify your backend services. You have your mobile application, it shows things to your users, but at one moment in time, it needs to go to the backend, maybe for login operations, profile operations, notifications, informations, all that goes back to the backend. And when we design a backend, we always have a wish list. We want the backend to be not really expensive. Again, when I start a new service, I may not have the capability to afford a huge infrastructure. So I don't want it to cost me too much. But at the same time, and on the other hand, what I want is my application to be highly scalable. Highly scalable means somebody found my application so cool that it tweeted that. And a gazillion people wanted to use my application right away. And this is a massive scale, going from one single user to maybe 10 million users. So what I want is my backend to be able to cope with that without any manual intervention. So this is what I want. Second, I also want to have a backend that evolves with my application with a very, very reduced time to market. Each time I create a new feature in my application, I just want to push that feature instead of redeploying completely the application. I just want to push the feature, and the feature is online, and my 10 million users are able to do that. So this is my wish list. And in terms of functionalities, feature, I want to be able to handle my users. I want to be able to notify my users, whether they're on their mobile application or through a website, and I want my backend to handle all my application logic. This is my wish list for an application. This is what we're going to try and do in the next minutes. So if I wanted to map my wish list on AWS services, that would be the services I may use. First, Amazon Cognito is a service that allows you to handle identities. Either your own identities, I mean the users that you create and that you want to handle, but also the users that you may federate with other identities providers, like public identities providers like Twitter, Facebook, Google, Amazon. So this is something that allows you to log in with a known public provider and take this identity for your own application without the need of a huge database with all your users and their preferences and all that stuff. You also want to do some analysis. Let's say analytics. How many users do I have? What's my ARPU? What's the evolution? What's the number of sessions? All this information are really important for a mobile application, especially if it generates money. So you want to have all the analytics. Then we can use another service here called Amazon Mobile Analytics. Simple. It's already in the SDK. The only thing you have to do is just flip a switch and say, yes, I want analytics, and all the rest will be taken care of by the SDK. Then to run the business logic, we've been through Lambda in the past 5 minutes, and we'll go a little bit deeper. For the user-generated content, like my profile picture, my preferences, my personal information, or whatever, then I can use Amazon S3. because you can store the number, an unlimited number of files into our store. Then, when you have a mobile application, what you want to do also is notify your users. You want to notify them using Apple servers, Google servers, Microsoft servers. Maybe if you're targeting China, going to Baidu, for example. So if you want to do that, then there's also a service for that at Amazon Web Services called SNS, Simple Notification Service, that will simplify sending notification to your mobile users. And then last but not least, at one moment in time, we may have the need for a database. And again, what you want to do is just handle your users and do your own business, not do the management for your database. And Amazon DynamoDB is a NoSQL database. It's a managed NoSQL database, scalable with high performances. So we'll go through all of this during the presentation, but let's just define what our application should look like, what the features should be. First, I want to be able, I want my user to be able to log in, define its own profile, define the location, and list the interests so that the application is able to find nearby users with the same interests and notify the users based on these interests. This is what my application should do, actually yours. For that, we can try and think in layers where we define what the user have to do, what the user will do, and what would be the interactions between the current user and the other users on my application. And this is also the way we will develop the application, going through these layers. First layer, user creation, user login, profile storage, and usage. For that, we can use Amazon Web Services SDK. We provide an SDK for many mobile platforms, including iOS, Android, Unity, and Xamarin. So if you want to make multi-platform, you can use that. So we provide an SDK that embraces all the services that we just touched a few minutes before. So for example, I can call a Lambda directly from the mobile device of my user. I can fetch information from a database directly from the mobile of my user. But on top of all that, I can use Cognito here to do the login and to handle user preferences and to handle user preferences synchronization among every device of the user and my backend. So this is what we're going to use. Whatever your platform is, there is an SDK that will help you access directly Amazon Web Services services. Okay? So first of all, we want to just log in. And once we're logged in, what we want is use the SDK to be able to get access to all the services of the application. But not everybody should be able to access your data. You don't want unidentified users to get access to the profiles of your current users. For security purposes, this is not allowed. For regulation purposes, this is not allowed. You're not allowed to share profile information of your users if they didn't give you consent before. So from a security standpoint and a regulation standpoint, you have to be sure that you have the right user at the right moment and that you allow this user to do what you want him to do, but not more. So for that, we're going to use all the services based on Amazon Web Services. We have our mobile client with our user. The first thing that you will do in the SDK is use one of our services called Security Token Service. That is a token vending machine that would allow you to provide a security token to your user based on his own credential on your system. So the user logs in, and in exchange, you provide him with a security token. The security token is based on the fact that you already defined in a service called AIM, Identity and Access Management, the things that the user is able to do or not. Once all those permissions have been validated, then you provide to the mobile user temporary credentials. So you give the credentials back so that a user is able to fetch all the information from the services. These credentials are temporary. They are rotated so that if the mobile is stolen or if someone cracks your application, there is absolutely no trace of credentials. You don't put any credential into your code. There is no lack. There is no security problem because you do not put any credential in your own code. So this is true for the code of your application, but this is also true for the credentials that you often put in your code and then you upload your code to GitHub and a few minutes later someone finds that and uses your own credential to use your applications. So using this type of mechanism allows you to avoid writing any credential in your code. Fully secured. Then once the user, and I mean the mobile client has the credentials, then he's happy to sign his own API calls. So you provide a user with temporary credentials that are used to sign the API calls to your backend. So you have a secure way to provide mobile features to your customers through your end users. Okay? Any questions? Credentials is, it's a kind of a login password. Sorry, the question was, what do you mean by credentials? The credentials are the elements that allow you to log into your system. When it's AWS, the credentials are based on one secret key and one identification key. So if we follow that path, you just get your token, and based on that token, you will receive a secret key and an identification key that will allow you to browse the services on AWS. So these are their credentials. And as a AWS customer today, you already have this kind of credentials as a developer, and these are the credentials you should never leave in your code if you want to be sure not to be hacked at one moment in time. Other questions? Okay. So for the user authentication, we can use Cognito Service. Cognito Service is the one that provides the temporary credentials for you, and it allows you either anonymous connections. Let's just imagine a game, a freemium game, where the first thing you want to do is just to have multiple customers jumping into the platform, but without asking them to specifically create an account, etc. You can do that. So we can create an identity that is anonymous, but that is constant over time. So the same user on the same device will always have the same identity, even if it is anonymous. Very good for analytics, for example. Very good for that. But if you don't want them to be anonymous, you can either use your own user database with their own users' logins and passwords, or you can use federation services so that you can use Twitter, Facebook, Google, and Amazon identity services, or whatever identity provider that complies with the OpenID. So if you have already identity providers, or if you want your user to log in with Facebook, use Cognito. It will help you. Okay? Great. Let's just go through a small example. Sorry for the colors, but you will get the slides afterwards. So this is the way we use Cognito in iOS. A few lines of code, and if you just want to go through that, we'll define that our credentials provider, so the entity that will provide the credentials, is my Cognito account. So I define a Cognito account, which is called identity pool ID. So I just define a Cognito account saying all my users will be handled by this Cognito account. Full stop. And if the user is recognized by Cognito, then the last line says my service manager, I mean the entry point to AWS services, will have the Cognito credential provider as a credential provider. There is no other place in your code where you will have to handle credentials. Everything will be handled automatically by the SDK, key rotation, token refreshing, And all this kind of automated elements are handled by the SDK. So you have to focus on your own application and not the security features that allow you to get the services from AWS. So pretty cool. Cognito offers also a set of data stores. So once I have an identity, would it be anonymous or identified, I have the possibility to have a local data store. Local data store is a very simple key value store, local to the device, but that is synchronized with all the devices for the same user. So if you have a user having an iPad, an iPhone, a Windows phone, and maybe other devices, once it's connected on the first and defines his own profile, when he logs on the second device, he will get his profile back. Nothing else to do than just these few lines of code. I just get an object being a Cognito dataset, fill the information for it. For example, here we're defining 2 keys and 2 values for these keys, name and interest. And once I've done that, once I just call the synchronize method on the object, then the object is fully synchronized on all the devices. So I can switch device as an end user, I can switch devices, I still get my profile. Few lines of code. Again, you focus on your own application, we handle the heavy lifting. Okay, that was in my wish list, trying to handle the heavy lifting as less as possible. Great. Now in the profile, very often, and specifically in this kind of findMatch application, you often upload your profile picture, or you upload pictures of elements that you do love in terms of your interests. Again, what we can do is use S3 as a destination for all these assets. That can be huge if your application is really into that. But in the SDK, we have utilities that will help you to do that. And one of the utilities is the transfer manager. And this is the way to upload an asset to S3. Again, using the SDK, you just ask the transfer utility to transfer the data to a bucket. A bucket is a place into S3 where we can put the files. So again, 1 line of code and you're able to upload directly all that. It's totally asynchronous, so you can have an upload in the background. You can do whatever you want. It's based on tasks so that you can see the upload operations in real time, but it will do that for you. So once the customer is, your end customer is defining his own profile and uploading photos, then you can use this line of code to upload the photos directly. Question for you, how do you think this is possible? How do you think that using this line of code, you can upload in a secure way the assets to S3? That's a good question, right? Answer is, it's possible because just before you've been using Cognito. Cognito provided you with the right credentials, and it provided you with the authorization to upload assets at a specific location into S3. So this is completely secured thanks to the login operations that we've been doing with Cognito before. Great. Now we have a user that's able to log in, that's able to define his own profile. But what we want to know is how many users we have concurrently, how many users we gained, maybe how much money we made since the launch of the application. And this is feasible with Amazon Mobile Analytics. Again, it's a simple call from the SDK, AWS Mobile Analytics for App ID. That's it. That's the only thing you have to do in your application. So once you launch the application, you make that call, and then the SDK will handle the rest. So you may ask the question, what would be the result? That's the result. So once you put the previous line of code, that one, then it will generate you that in the Amazon Web Services console. So again, focus on your application, your business logic, and we will handle the rest thanks to the SDK. So we have a few metrics that are already available automatically, but you can define your own metrics if it's needed. So it's a matter of making another call with the SDK, but you can create your own metrics. I don't know, maybe the guy in the game handled the sword, or the other one bought flowers, whatever. You can define your own specific events that are handled here, and you have all the statistics based on these specific custom events. So we have analytics, and we have finished the first layer. Wonderful. We're able to have users jump into our application. Now comes the core part of the application. Remember, it's a find-match type of application. So you need to define exactly where you are, and you need to know exactly if there are people with the same interests, sharing the same interest in a radius. So this is the, let's say, the core part of the application, and we will go through it the same way. Wonderful. So in a real life type of application, this is how it works. You have your mobile, and the mobile provides the information to the backend, and the backend stores that somewhere, some way. Okay? So if we want to map that with AWS services, this would be the way we would do that. The public facing of your backend could be used, could be created using API gateway. API gateway, Amazon API gateway is a service that allows you to create RESTful APIs with the multiple clicks in the console, but just define your own API. And based on the calls on each and every API, you can invoke a Lambda function. So let's just imagine that we create an API with two methods. First one being location, second one being interests. So when I go in /location, I can provide my own location. If I do a /interest, maybe I can update my profile with my own interest. In each case, this will invoke a Lambda function. One of these Lambda functions, for example, report location. This would be the first thing that we want to do with the application. I want to report my current location so that people may find my, my own user with the same interests. And what I can do is, once I have reported my location, I may be able to store it into a kind of a database that would be Amazon DynamoDB, for example. How do we do that? First of all, let's just step back a minute and say how we may be able to report our location. Does anybody know about Geohash? Yay, few people know about Geohash. Geohash is something absolutely wonderful. When you want to know a location in the world, the usual way to do that is to use latitude and longitude. This is my position. It's often expressed in degrees, so it's very easy to see as a human, but for a machine, it's very complicated. Degrees, minutes, seconds, west, north, etc. So many people have been working on that, and they found a way to hash latitude and longitude. And that hash is pretty much smart because it divides the planet in few planes. So we have 6 planes that describe the entire planet, and each of these planes is a cell, and you can split the cell. So let's take, for example, here we have face A of the cube, and down there we divided the face A in 4 cells, and each cell can be in turn divided in 4 cells. That in turn can be divided in 4 cells. That in turns can be divided in 4 cells, etc., etc., etc. So we can define that red dot here is located at position A224 because it's side A of the cube, bigger cell number 2, smaller cell number 2, smaller cell number 4. And this kind of hashes can be expressed as integers. Wonderful. Expressing a location as a single integer is wonderful for a database, because if I want to find people nearby me, then that would be just a range. I want to find people that have a geohash between that value and that other value. Neat, isn't it? So if it works with a database, then it may work with a NoSQL database that works with keys and ranges. See? Key, range, geohash. We'll have a system that is able to find people in nearby locations without any calculation. There is no calculation done here except the hashing of the latitude and longitude. So this is wonderful, because if there is no calculation, then the compute time would be smaller. If the compute time is smaller, what would be the benefits? Yeah, first benefit, faster answer. Second benefit? Save battery. Let's just imagine that this calculation is made on the back end. What would be the benefit? Sorry? Yes, absolutely. It's cheaper. The less I compute, the less I pay. So if I find something that doesn't do any compute, wonderful, I won. Great, so we'll be using Geohash concepts. And it happens, what a surprise, it happens that our DynamoDB NoSQL managed database handles geohashing. So it's pretty easy. We have an SDK. Once you have a Lambda, obtaining the latitude and longitude, then our SDK is able to change that into Geohash and store that directly into a DynamoDB table. All that's made for you. How do we do that? This is not the right example. The right example should be, GeoPoint is a new GeoPoint with latitude and longitude, and then we just make a call to GeoData Manager put point, full stop. So I get a position from a user, I just do a put point, full stop. Very short, less expensive. And this is what we do with Lambda and DynamoDB. So that's wonderful. I have a user is able to log in, change his profile, provide information, upload user-generated content, and able to report his own location. And I have stored his own location. I'm already done. So we'll continue through the path of doing a RESTful API. Remember, we have two entry points in the RESTful API. The first one was report location, and the other one was interest. So to define this kind of APIs, we're going to use Amazon API Gateway. Amazon API Gateway is a service where you define programmatically or through clicks a complete RESTful API with all the verbs. And you do the mapping between the RESTful API words and your own code. Your own code could be a Lambda function. This is what we're going to do in the presentation today. But that could be an existing endpoint, no problem. Or that could be another AWS API or whatever. So you can call whatever you want behind this kind of APIs. But the API will be handled by Amazon Web Services for you. What would be the benefits for that? The first benefit would be it's handled by Amazon. So the scalability is not a problem for me as a developer. I will not have to handle auto-scaling groups of API servers that will do the job for me. I won't have to develop my own API server. Anybody using some frameworks for developing APIs, backends? Symfony, for example? Sorry? Play framework? Wonderful. Other frameworks? Great. Some in Node.js, please. Express? Wonderful. So you have many different frameworks to develop your own APIs. Now just imagine that you just stop using these frameworks and developing your own APIs. You will do that through a point-and-click interface and define the APIs that way. How do I handle with Play Framework, Express, Symfony? How do I handle throttling? By the way, are you implementing throttling in your APIs? Do you know what throttling is? Throttling is a way to say I have too much users on my API, so I will then reduce their ability to make calls on my API. It's interesting for two things. First one is just to be sure that my service will still be up even though I have too many users to be able to cope with. Second is interesting for hackers trying to make DDoS on you, making too much requests per second on the same API. You have to handle that in your own APIs. Are you implementing that? The answer should be yes. If it's no, don't answer. If it's yes, say, yeah, I'm doing that. If you're not doing that, you can use API Gateway. It's just a value. You say, I limit my number of calls to 1,000 per second. I limit my number of calls to 10,000 per second. And this is handled by AWS for you. So this is a way of using the elements for our backend. Great. So we have our 2 layers. Now we have the guy that's logged in, defined his profile, reported his own location, and the location is stored. What's the way to make other user aware that the guy is very interesting and is less than 10 kilometers away? This is our 3rd layer. Great. How do we match the users? That's the current situation now. We have location that is reported here in the upper left corner in our database. We have user-generated content in our S3, and we have people updating their profiles regularly, and this is exactly what's happening right now. So the only thing we have to do is try a way to synchronize all these elements all together. These are events. So if these are events, what would be the service that would be really legitimate here? Yeah, I heard that. Amazon Lambda. Wonderful. Just because everything is event-based. And if everything is event-based, then I can use Lambda. So how can I do that? For my database, DynamoDB Streams is a feature that fires an event each time a record is modified or created. Wonderful. What are the events that we are creating right now? We're just creating an event each time a user is reporting a location. Wonderful. This is exactly what we're expecting to do. I want to know when a user is updating his own location, that I'm able to give the guy the list of people that may match his own interests. Great. When I push a new photo into my S3 bucket, this is an event. I may be able to push this new photo to someone really interested in my user. So each time I have a new photo, I can handle this kind of event. Again, here, when I change my interest radius, I mean, I'm not looking for people close to me, but I'm looking for people, let's say, in a radius of 100 kilometers. I will change my profile. This is an event. Then this can be handled by a AWS Lambda, Amazon Lambda operation. Great, we have everything. Let's go for it. So what would be the way to use that? So first of all, we have the /location API that is called, where we do the report location. Based on that API, we'll invoke a Lambda function called report location that will hash the location, store it into a DynamoDB table. Once the record is stored, it generates an event. This event will then trigger a new Lambda called findMatch. So I will find a match. I will try and find a match each time there's a user trying to update his location. And I will then make use of the existing data. First data existing, the interest table, so all the interests and the people that are stored in that table, and the profiles of the guys that are comparable to my interests. I have everything, so I will just do that. Other thing, I'm just defining new interests. So I call the /interest API that will in turn trigger a Lambda function. This Lambda function will update some table. Once the table is updated, what should I have to do? Find a match. And we're done. Our application is almost finished. So this is one example of code when you change a record in a database. This is Node.js code. So once you change a record in a database, you get an event and you can handle the event that way. Here, for example, we have a for each loop that handles many events at one time. Easy. I'm just finding the new location, that is one field of the event, and I will try and find a match for that location. Full stop. Code is not really impressive, right? Just a few lines of code, and it works. It's okay. I changed my location. The system found some friends for me. Now I need the system to notify me that I have some users. Then we will use one service called Amazon SNS push notification. SNS push notification is a service that will allow you, with a simple API call, to send push notification to many different operators. Today, if you make that the standard way, what do you have to do? You have to have servers for the Apple push notification service. Then you have to have servers for the Google push service. Then you will have to have servers for Baidu if you want to focus on China. Then you have to have servers for Amazon Mobile, and that is necessary because you will target Amazon people, I'm sure. And you will have to have servers for Windows servers, mobiles. So this is the classical way. If you do that the SNS way, it's just one API call. Full stop. So I just want to send a push. So this is much easier, and again, it really takes the heavy lifting for you, and you just focus on your application and your application logic. Great. So let's get back to our stream before. So either I'm modifying my interest table or my Geohash table, I mean the location table, and this will start a Lambda function. This will invoke a Lambda function, and that Lambda function will, with just one line of code, call Amazon SNS so that there will be a push notification on the users that are concerned by the location and the interests. That's the way it works. Full stop. Before we go to that part, have you count the number of servers that we've been using up to now? None. No servers. Have you seen a limit in the number of users? Nope. Is this type of architecture dedicated to a specific number of users? I mean, do we have to have 100,000 users or 1 million users to be able to use that architecture? Or what is the minimum number of users that is required for this kind of architecture? None. One. That's right. Just one. Isn't it neat? What would be the cost with 0 users? Difficult exercise. So there's no need to have a right answer. Very small price. Yeah. Very small price for a very small number of users. What if the number of users grows? That will never be expensive. That will cost more. But the thing is, the costs will be in line with your activity. So if it costs you more, this means that you're doing more business. That may mean that you're making more money. So this kind of architecture is really interesting because the bill goes with your activity. Now, what will be the time spent to do administration operations on your servers? 0. No servers, no admin. Still, you have to do the admin on the databases. Don't forget that. But actually, no servers, no admin. Stop. So this is one of the very interesting architectures where you can focus on your business and not on the infrastructure. So let's just finish with that. If I change my profile, because I've been doing everything in application, I can log in, I can define my profile, I can report my location, I am notified when I have new friends in the area, but I still did not have change my, one, two, three, I still haven't changed my profile. If I change my profile, what happens, according to you? It generates an event. And if it generates an event, what I can do is trigger a Lambda function. Wonderful. So this is this kind of event that is triggered when I change my profile. I just get an event with the old values and new values for the data store where I stored my profile. The profile has been changed by the user locally on his device. I call the synchronize method on the dataset. This generates an event on the back end where you can take the event and make the changes you want with it. What am I doing here? I'm calling a Lambda function. I'm calling the findMatch Lambda function. So when I'm changing my profile, the first thing I do is update the profile and then find a match. So all the use cases have been handled in this application. Great, wonderful. We've been through everything. Final architecture, that's the question. Where are the servers? No servers. Oops, photo. So that's the final architecture. Okay, so we're finished with that. That would be time for questions now, but just as a recap, do we have achieved all the elements that were in our wish list? Yes, absolutely. It's scalable, it's secure, it handles the heavy lifting for me. I can do whatever I want. I can focus on my custom application logic and not focus on infrastructure, and it's fully reliable. Wonderful. Okay, we can go further now, because what you've seen is I've been developing an application that actually works, but we can go much further. First of all, if you want to test your mobile application, you can use another service called AWS Device Farm. We have physical devices in many data centers that are here to test your application. iOS, Android. So just push your application, we can do the test for you. So this is a service. You can use other data warehousing services more than the analytics you've been using up to now. Get the information from Amazon Mobile Analytics, export them into a data warehouse called Amazon Redshift, and make very complicated queries made by your data scientists. You can do that. You can customize your notification, go a little bit further with the notification. You can, it's fun, you can watermark your pictures. This is a test you can do getting back home directly. When you push a file into S3 and this file is a JPEG file or an image file, you can have a Lambda just watermarking it for your copyrights, so you can make your application more secure again. Great. So once we have answered the questions and you're getting back home, this is what you can do next. Just go on aws.amazon.com/SDK, and you'll be able to download the SDK we've been through during the last hour and make the tests. That's wonderful. That's pretty easy. And there's a new service that has been released in beta version a few weeks ago, 3 weeks ago, called Mobile Hub. Mobile Hub is a service where you point and click and define exactly what your application needs to be and what are the services you want to use in AWS. And it will generate for you the configuration of all the services, and it will generate for you the application. So you'll be able to download the Xcode version of the application, for example, or the Java version. So you will get the skeleton, and you will just have to put your own application logic. So you can start with that. Go home, go to Mobile Hub, click a few clicks, and then you will be able to start from scratch a complete new mobile application with many of the code already defined for you. Right? So thank you very much for listening. I guess we have a few minutes for questions. So I will be really happy to answer these questions. Again, if you're shy to have a very French accent, either I'll be able to take the same accent, or you can just ask in French and I will rephrase in English for the video. Right? Questions? Just wait for the mic.
Hello. I'm probably a bad developer, but I need a debugger. And what's happened for Lambda in the server part?
Very good question. Lambda is managed code, sorry? Oh, sorry. Question was, I need a debugger writing Lambda code. You can do that, actually, because Lambda is about execution. So for developing and testing your application, you can use the usual environments. You want to do that with Java, you can use your Eclipse environment, do the test locally. so that you can go through the debugger and all that stuff. If you're doing with Node.js, you can use the usual stuff that are a little bit less advanced than Eclipse. You can do all the things locally, test locally, and there's no problem. Now, if you want to know exactly what happens during the real execution time, you also have the ability, actually it's not an ability, it runs by default. It generates logs directly into CloudWatch logs. So you have a trace of exactly what's happening into a Lambda. So it's a postmortem because you cannot do debugging real time with the operations, but you have all the information to be able to debug your Lambda if it does not work correctly. Yep. Thanks.
Is it possible to replay an event?
To replay an event?
Yeah, in case of failure.
Yes. It's a default feature. So when you have many events cascading, I mean, when you put a file into S3 that generates an event that triggers a Lambda, if the Lambda fails, then S3 will replay the event automatically. So it's by default. When you have events that are generated by AWS services, if the Lambda fails for whatever reason, we will replay the event. Based on the services, the replay will be a bit different. Sometimes it's indefinite replay. Sometimes it's just a few times replay. But it's a feature. Nothing to do. It will be replayed if you need it. Have I answered the question? Yeah? Great. Oh, sorry. The question was, is there a possibility to replay the event? The answer is yes, by default. Other questions? Yep.
A big problem in dating apps is bots and spam accounts.
Yep.
Do you provide any solutions to reduce or eliminate those?
Question is, main problem with dating apps is non-real humans with bots and fake profiles and all that stuff. I would say that this is much more a feature of your application identifying fake users. So we do not provide specific services that may identify that a user is not a user, by the way, or is that it's a robot or a fake profile. So we don't have this kind of service. But what you can do is try and check through our ecosystem. We have many people giving you frameworks, elements. The easiest one would be CAPTCHAs, for example, but we do not provide as AWS this kind of services. Great. Other questions? Yep.
How would you compare your solution with a BaaS like Parse.com, which provide SDK for the different platform? And even if it's with a server, it's quite easy to use and to handle.
Question is, how do you compare the presentation of today with PaaS offering, platform as a service offerings, where everything is already handled and you have an SDK that allows you to call the pre-built backend? The answer is pre-built backend, I mean platform as a service, compared to your own business. Sometimes the platform as a service offering is pretty much interesting because it's already built and you just have to turn some knobs and that's it. And you have a solution with a very short time to market, but it much more a one-size-fits-all type of offering. So if you are in the PaaS offering, then wonderful, you can use it. Once you want to get a little bit, you want to stretch a little bit the offering, that gets difficult. So the main difference between what we saw today and a PaaS offering, what we saw today, you can define what you want. The example I gave is just using different building blocks to set up a solution. I could have set up a completely different solution based on completely different building blocks, but that may fit much better with my application. Okay, so that's the difference, and this is not specific to dating apps. It's specific to everything you can find in the cloud. PaaS is great because it's very short time to market, but it's much more a one-size-fits-all. Compared to I can use my own building blocks and create my own specific intellectual property type based application on the different building blocks. That's the difference. Other questions? Nope. Yep, there's a question here.
Just one quick question. Is it possible to use other JVM-based languages instead of Java, like Scala, Clojure, whatever?
Are the camera running? Are we on camera? Yes? No, it's not possible. Actually, you have 3 type of languages that are supported: Java, JavaScript, and Python, sorry. If you want to run other languages, just type in Google, I want to run Scala, for example, and you will find very good solutions. On the other answer is, we know that you want much more languages. We're working on that, so please stay tuned. But while we provide something new, just Google it. And there are very good answers, very. Oh, sorry. The question was, can I use other development languages in my Lambdas? The answer is yes. Sorry. Other questions? Great, wonderful. So thank you very much for your time. Merci beaucoup d'être venu. If you need more information, just ask. We have 3 Amazonians in the room. Please stand up. So the 2 people are here in the same team here in Paris. I'm the 3rd. So if you have more questions, just ask us, or just go through TheFamily, and they'll make the relationship between you and ourselves. If you need architecture information, architects are here to help you. It's free, so please ask it. Go through, again, TheFamily for the organization and all the programs that we have with the startups. We have many programs. So just ask, and we'll be here to help you. Okay? Thank you very much again for your time.